Good day and welcome to our presentation regarding ocean acidification. In total, there are 4 presenters including me, Chua Tiong Wei, the second, Cheng Sheng Yang, the third, Yo Ka Chun, and lastly, Chai Kiet Keng. I will be doing an intro to ocean acidification. Ocean acidification is the ongoing decrease in the pH of the Earth's ocean, caused by the uptake of carbon dioxide from the atmosphere. So now let's watch a video about ocean acidification.
By now you've heard that the way we're living is filling up our atmosphere with carbon dioxide. As a result, the planet's warming. Heat waves and floods are more likely to be extreme, and people's lives will get tougher. And the more we learn about climate change, the more risks we uncover. Since we started burning fossil fuels, the ocean has absorbed about half of all the CO2 we humans have put out. That's why it's called the planet's biggest carbon sink. Now this is good because it's kept a lot of CO2 out of the atmosphere. But as the ocean warms, it takes up less and less CO2. And with all that CO2 in the sea, scientists are shedding light on, well, an ocean of problems. Ready for the first big problem? Some sea creatures like clams, oysters, and coral, their shells and skeletons are getting weaker. Okay, you've got bigger problems than easy-to-crack clams? Maybe not if you're among the 1 in 7 people who get most of their protein from seafood. Or if you understand how unstable the world would be with a billion more hungry people. What's weakening the shells? Well, these little creatures are going about their lives scooping up molecules called carbonate ions to be the building blocks of their shells. But when CO2 reacts with seawater, it releases hydrogen ions, which compete with shells for carbonate. With more hydrogen ions floating around in the ocean, our little friends have to spend more energy building their shells and have less energy for finding food. That means it's harder to grow, and more will die off before they get big. So the fish that eat the clams or live among the coral will have a harder time surviving, meaning the fish that dine on them won't have enough to eat, and so we won't have enough to eat. Remember those pesky hydrogen ions generated by more CO2? They don't just take away the carbonate ions that these little clams need. They also make the ocean more acidic. It's already become 30% more acidic since we started spewing all this CO2, and it could get much worse. We could change the ocean's chemistry so much that shells actually start to dissolve. That means if we don't turn this problem around, your great-grandkids might think of reefs the way you think of a dodo bird. And with 1 in 4 ocean species living in coral reef ecosystems, weaker coral could threaten the foundation of the whole ocean food chain. But why panic, right? Life always seems to find a way to adapt, but it needs time. In a few decades, we might make the oceans more acidic than they've been in 20 million years. It's hard to imagine any ecosystem quickly adapting to that big of a change. But things don't have to get that bad. We've started this problem, and we're going to fix it, beginning at its source, carbon dioxide from burning fossil fuels.
Continuing my introduction, calcium carbonate minerals are the building blocks for the skeletons and shells of many marine organisms. The oceans are supersaturated with calcium carbonate minerals, which are used as building blocks for calcifying organisms such as shells or crabs. Ocean acidification causes these building blocks to be undersaturated, which will affect organisms in maintaining their shells. It was estimated about 30 to 40% of CO2 from human activities released into the atmosphere, more than a 15% CO2 which has been absorbed into the ocean. About 525 billion tons of CO2 has been released and 25 million tons added per day. Since the beginning of Industrial Revolution, pH has fallen by 0.1. Approximate to 30% increase in pH, which is a big step. Experts estimate pH to increase nearly 150%, which is a value haven't experienced since 20 million years ago.
Now I would like to talk about the causes that leads to ocean acidification. There are 2 main causes, which are the burning of fossil fuels and the algae blooms. The demand of the fossil fuels keep on increasing since the Industrial Revolution. The burning of fuels increasing the level of carbon dioxide release into the atmosphere and end up will be absorbed by the surface of ocean. The following slide is showing the chemical reaction of carbon dioxide absorbed by the oceans. When the oceans combine with the carbon dioxide, they will form the carbonic acid. This acid will release the hydrogen ion to the sea, which causes the drop of pH level of the ocean. Once the pH level decreases, the availability of the carbonate ions for the marine organism will also decrease. Therefore, hard for them to build the calcium carbonate shell and skeleton. For the algae bloom, the causes is due to the excess nutrients runoff from the animal farm and the influx of carbon dioxide from the atmosphere, which will rapid the algae growth. When the algae dies, the bacteria will use the dissolved oxygen for decomposing them. So, this will decrease the oxygen availability for the marine organism. Eventually, a dead zone is occurred. The marine organism will start to die off and bacteria will decompose them. Therefore, the carbon dioxide concentration will be increased due to the degradation of excessive organic matter, and hence the pH of the seawater is decreased.
Right now, I would like to talk about the impact of the ocean acidification. Since 1958, the atmospheric carbon dioxide level has been increasing constantly until the year 2018, with 8.28 ppm. Similarly, in 1988, scientists discovered that the level of carbon dioxide in the ocean also showing an identical growth rate as the atmospheric carbon dioxide level, with 8.28 ppi. As the level of the carbon dioxide increased, the pH of the ocean dropped down accordingly throughout the years. The direct impact was shown on the Alaska fishery industry in terms of the biologic response from the population of the red king and tanner crab decreased significantly as their larvae cannot survive and adapt to the acidic environment. At the same time, the coral reef population also showing a similar surviving pattern, which they also cannot adapt and survive in the acidic living environment. On the other hand, there are some organisms like gadders, calcogrammus, and microbio herringus having a well-developed acid-base regulatory system and high metabolic rate within themselves to allow them survive and adapt to the acidic environment. Next, for the planktonic organisms like Pseudocalanus acupus, which belong to the copepod species, showing an increasing in the number as the concentration of the carbon dioxide that keep on increasing becoming a cofactor which trigger their growth and increase the amount of the copepod. The top-down control in the food web exert less effect toward them as they having a different choices. Microbio, which having a smaller size compared with the copepod, made them becoming an alternative food source from the copepod to increase their population. As there are more copepod, the acid production by them will further decrease down the pH of the ocean, which resulting ocean acidification.
The cause of ocean acidification is mainly caused by human activities. Since the industrialization era until now, we are heavily dependent on fossil fuel to run most of our daily chores such as cooking, electricity, and driving. These leave behind high carbon footprint which react with ocean to form carbonic acid. As the rate of carbonic acid formation is greater than the elimination, the ocean pH will continue to rise as time passes. Hence, how can we prevent ocean acidification? Of course, when there are problems, there are solutions. One of the many solutions is for normal people like us, we can educate other people about the ocean acidification and its threats. And after we educate them, we can try to enforce tight control of carbon dioxide emission by enforcing stricter law and etc. For scientists and engineers, there are geoengineering and plant engineering. We will get to that now. For normal people, as I said before, education is the key. To teach people how ocean acidification affects everyone in a great food chain and how long-term effect will affect on us, such as lower pH will create lower marine life and thus lesser food for us and higher price for us to pay. And enforcing rule and introducing new bills will reduce carbon footprint. Less carbon emitted, less carbon go into the ocean. For scientists and engineers, there are two ways. One of it is geoengineering, which is the process of capturing carbon dioxide and remove them. How? Is by capturing them in a filter, then compress them into a liquid and store it under some geothermic vents or some caves, which are able to store it for a long term. And another solution is by producing more seaweeds. Why? Because seaweeds are able to remove 53 billion tons of CO2 per year. If we create or capture more seaweed, it will absorb more CO2. But how are we going to limit them? We will bury the seaweed by sedimentation. Once the seaweed sediment underwater, it will remain there for a long time, which will reduce the CO2 emission.
In conclusion, ocean acidification is a global threat to various marine life which increases pH of the ocean. Two of the main causes, such as burning of fossil fuels and algae bloom, have been discussed before. Ocean acidification has seriously impacted the marine life in terms of the overall biology response, where the food chain has been disrupted and heavily affected the food web, which impacted the death of various marine life. Examples of resolution is through education and science such as geoengineering and plant engineering.